February 15th, 2017. Guys, I wouldn't worry about the specific ways the formaldehyde forms because I realize that there's a hell of a lot more to that. And with the kind of terminology that's there, people will just be lost in the sauce real fast. So as long as we can just get some type of animation of it clumping together, that's good enough. If they want to dive into the specifics of it, they can read up on it themselves. That being said, I missed a very large part of the generalizations required to understand this, and some basic differences between establishment and the way they do their stardust chemical reactions and the way stellar metamorphosis presents it. For the most part, with establishment, you have a large molecular cloud or dust cloud. It's very diffuse, there's no gravitation in it, and you have stars on the other side, and they radiate outwards, and they push material to make shock waves inside of that molecular cloud. And inside that shocked material is the dust grains, and on top of the dust grains, on the surface of them, are where the chemical reactions take place. I don't know if you can see that. You have your large molecular cloud, and you have your young stars, which then radiate outwards, making the shock-waved area where the dust cloud is. This is where the chemicals form on the surface of the dust grain. Now, that is problematic because they have two things. They have a large molecular diffuse cloud with no gravitation, and they have young stars. Now, the solution to this is to realize that intermediate age stars are the dust clouds, and they're older, obviously, than the young stars. The way to fix that is to take the dust grain, which is about 1 micron in diameter, and place it interacting and landing inside of that intermediate age star, probably a brown dwarf. The brown dwarf is probably where it's cool enough to where it won't radiate it back out again in solar wind or flaring and all that good stuff. For the most part. I mean, there are probably exceptions to the rule, but that's where I'm going. Usually, when they're dim enough and they're not energetic enough to eject the material out on their own without having to be irradiated or ripped away by a younger, hotter host. But the reason why I wanted to go over this is that you have a locus of attention. You have astronomers looking at these big clouds saying that's where the chemical reactions take place, that's where life begins, yet clearly in stellar metamorphosis life begins on the star itself. So what you do is you place all those dust grains entering into the intermediate age star, and that's where it happens. It's a much simpler understanding. It's an Occam's razor. Instead of having two objects, the young star and the intermolecular dust cloud, you combine them together, but you make two changes. One, you make the dust cloud as being the evolving star itself, as well as you push the age of the young stars down to where they're old enough to where they cannot radiate anymore and lose the material to solar wind. So that's an Occam's razor there. Two objects instead of two, having one. And the star is the dust and molecular gas cloud. It has the gravity to trap the material. A diffuse cloud like this doesn't have the gravity to trap the material. If you have a chemical reaction take place, the chemical will just keep on going through and won't react with anything else. It's too diffuse. How do you have large-scale chemistry happening on that? You don't. As well, the intermediate age star has the mechanical means to mix the material. We're getting pictures back from a recent satellite that's orbiting Jupiter right now, showing all these huge swirls of molecular clouds mixing all this stuff together mechanically. So not only is this hypothesis, well, testable, we can actually see the mechanical mixing of this material, and we can also see the material entering through large impacts and where the material breaks up. So we have two observations. We have the mechanical mixing and we have the material being trapped. We don't see asteroids or comets or anything coming out of Jupiter. It all enters Jupiter, and that's where the chemistry is taking place. And a little trivia: Earth itself is estimated to be collecting around 40,000 tons of the stardust per day. So if you want to calculate how much dust Jupiter or a brown dwarf or a Saturn type object is collecting, all you have to do is calculate the surface area of the Earth, and then, of course, it would be squared for the surface area of Jupiter, Saturn, Neptune, or Uranium, and you can figure out how much dust is entering into those atmospheres. It would be an easy calculation. It's just the surface of a sphere. And we'll see that there's a whole hell of a lot of chemistry going on. And I find it surprising how astronomers, they want to separate the process. I have no idea why they do that when they have clearly the mixing and the chemistry happening inside of an intermediate age star as it evolves. So I thought that was kind of weird. And the reason why I wanted to go over this as well is that it's very important to understand where astronomers are focusing their minds. Because if you can understand where they're focusing themselves, what they're looking at, you can see what they're missing. It's like if you're if you're a doctor and you're trying to figure out why somebody is in pain, and this is a really stupid joke, but I remember it. Say a person had a broken finger, okay, and they go to the doctor and they say, listen, everywhere I touch it hurts. It hurts on my knee, it hurts, on my head, it hurts on my ear, it hurts on my shoulder, it hurts on my foot. And astronomers, they go, well, your knee, your shoulder, your foot, your head, it all must be in pain because everywhere it touches it hurts. But if you had a different perspective, you realize that it's the finger that's broken. And that's what astronomers are doing. They're not understanding that their way they look at the world around them, what they focus on, is determining what they can see. And they don't have the theory to do that yet. That's why I'm working on this. As well, another idea I had, a good analogy for this is like the fact that they put chemistry outside of a star. It makes just as much sense as saying when you go to a pizza place and say you get a pizza or you get a sub or you get a beer or whatnot, and you set the pizza on the table, and then the pizza disintegrates and turns into poop on its own, thinking, well, it just has to be in the vicinity of the person with the chemical reactions, and then that's where it all takes place. No, the chemistry is happening inside the person when they digest the food. Same thing with chemistry in outer space. It doesn't happen in some mysterious gas cloud where we have to measure the X-rays and radio waves coming out of. It's happening right inside of the star itself. All they have to do is take their telescope and look at the fucking star, because that's where the chemistry is happening. It doesn't happen in some mysterious place in a big gas cloud, and we have to find where the chemicals are taking place in the molecular cloud. That's ridiculous. It's happening inside of a star. Same thing with digesting food. It happens inside of your body. It doesn't happen on the table when you're sitting there. It's weird to look at it like that, but alright, y'all, I think this is enough. Baz, I'll take a picture of this and email it to you so you can use it for some more ideas, collect them all up and stuff. Alright, everybody, take it easy.